Competition. It's the driving force keeping companies on top of their game. To stay on top, a company must constantly be on the move to improve their business, not how it is today, but how it will be tomorrow. What will keep them one step ahead of their competition? Re-engineering the product development process for flexibility and rapid response to changing business requirements is the key. And that key is realized through efficient data management, optimally using product information as a competitive advantage. Sabre Motors has been doing this for a number of years, and it's kept them on top, especially with their mid-size sports sedan, the Elite. The Elite's enjoyed being #1 in its class for several years, but the competition's been extremely tough. Today, it faces a major challenge from the Toyota Camry for the #1 spot in 1995.
Well, the Camry has made a major upgrade in its McPherson strut suspension system for 1995. They're attempting to appeal to the consumer's demand for a more aggressive, well-balanced ride from a mid-size sports sedan. So to maintain our leadership in this class, we've decided to make a bold move. We want to offer a combined package of ABS braking and active suspension, all controlled by one ICU, an intelligent control unit. It's really a major undertaking on our part, but one we feel is necessary to maintain our leadership position.
To undertake a course of action such as this, a company must be confident in both its resources and its infrastructure. Sabre Motors has a history of constantly and consistently rising to the challenge by always looking ahead, seeing how best to align itself to the job at hand. And one of the keys that Sabre's come to rely on is its agile product development process.
The automotive arena has always been one of constant change. Ever since Henry Ford began running Model Ts down an assembly line, the call has been for innovation and thinking about tomorrow. The concept of re-engineering is a way to maintain those principles. And a key part of constantly reconstructing our processes is having a virtual team of key suppliers as our extended enterprise. Now, back in the 1970s, we had a cadre of about 1,000 suppliers who worked on parts and components that made up about 20% of our automobiles. Today, we have fewer than 150 suppliers, not only designing and building parts and components, but also major subassemblies and assemblies that make up 70% of our automobiles. They are true partners in our business, and the relationships we form with them are critical to our success. In fact, today, we only need to concentrate on the activities at which we excel: body styling, powertrain, and final assembly.
For this project, we'll call on Intuitive Vehicle Systems, or IVS as we know them, to design and manufacture the suspension and brake assembly. Now, their technology matches ours, so we can offload a project such as this to them and still have an in-house sense of communication. Now, what I mean by this is I have this workflow management tool, which essentially provides me with the ability to define, monitor, and redefine any product development process that I have. Now, with this tool, I can define a new process with 4 major stages: concept, in-work, road test, and release. Since the project has been assigned to IVS, I can monitor them through this tool, and they can interact with me to keep me updated. I can assign milestones and control points along the process. Now, for example, I've put in a control point following the completion of the road test, and this creates a review cycle which I must approve before the project can be released for manufacturing. Now, I can make this review cycle simple so that it just involves my approval, or more inclusive, where it would require multiple approvals before its release. Right now, this project is in the concept stage at IVS with Doug Wainwright, one of their top mechanical engineers.
Our work with automotive manufacturers is about as challenging as you can get, but it's also very rewarding. We've been associated with Sabre Motors for just over 5 years, and every project has tested us and our abilities to the limit. Tighter time frames, the imperative to employ the latest technology, the need to articulate more sophisticated components. But when we see a report listing the Sabre Elite as the #1 midsize sports sedan for 3 years running since its inception, well, it's all worthwhile. This Sabre project provides some unique challenges to me and the team here at IVS. We've got to take the existing ABS braking system from the Elite, modify an existing active suspension we created for another manufacturer's upscale model, create an ICU to control both systems, and then fit the control unit and related harnessing into the engine compartment. Now, my first concern is with the real estate under the hood. There always seems to be a problem finding a suitable location for these types of components because the engine compartment in today's car is so tightly packed. Now, before I begin my design, I want to check my database for our best practices in creating these systems.
In his data management system, Doug finds multimedia documents which were created during past projects. They outline the proper steps involved in designing these types of systems, providing him with an invaluable roadmap for his current task at hand. Doug notes that he has mail from Evan Stokowski, the control system designer. Evan has analyzed the requirements for the ICU and has identified the necessary PC board space he'll need.
Now, I've checked my historical documentation on these types of assemblies, and I've gotten my PC board requirements from the control system designer. Now, by looking at my past documentation, I confirmed that the best location for the ICU will be high on the bulkhead, away from the water and heat. Now, what I suspected is true. With the board space required, there's an interference with one of the windshield wiper motors. See, now I need to discuss this with Ray Atkinson over at Sabre before I proceed.
Doug discovered this interference by looking at actual Sabre drawings on his system. He now contacts Ray to begin a CV conference. This conferencing capability will allow both Doug and Ray to view the actual part file that can be worked on by either party and discuss the pertinent issues involved.
Yeah, when I got the size requirements for the ICU, I was afraid this would be the case. As you can see here, the ICU placement clashes with the left side wiper motor.
Now, hold on a second, Doug. I don't think we have a problem here. Let me just check some documentation on this. Yes, just as I thought. I've got some good news for you. We're incorporating a single windshield wiper design for the 95 Elite, and we've got another supplier creating the design specs. Let me just change the authorization so you have read access to the wiper project document, and that should help you with the ICU placement.
Ray has the ability to authorize Doug to review the new windshield wiper design from another supplier because they all share the same technology. Once Ray has provided Doug with this access, Doug can call up the new design, overlay it with his existing design, and see that the interference is no longer a problem. Now, both suppliers have been added to each other's development project so that they will receive updated informational messages.
Okay, Ray, I see what I'm working with now. This shouldn't be a problem. I'll be in touch. All right, bye-bye. A simple conference on the phone and the screen alleviates a lot of problems for me. I'm able to eliminate the interference I was worried about, and I'm able to see what the other supplier is doing with their new wiper design. Now, without these capabilities at my fingertips, I could have spent days running down the wrong road.
Doug has completed the first stage of the process, the concept stage. He can now move on in the project to the in-work stage. Once he's done this, notification is automatically sent to every member of the team. Using the real estate requirements from the control system designer, Doug, with a simple query of his library, can browse through a number of existing designs. Doug finds several boxes which will serve his needs. He can call up the parts on his system and view them. From this, he can decide if one of them will suit the cabling and fitting requirements within the engine compartment. Doug finds the box he needs existing within the database and sends the physical specifications off by mail to Evan Stokowski, the control system designer.
When I received the mail from Doug containing the selected enclosure box, I was able to take my preliminary PC board design and tailor it to fit the box's exact measurement and features. It was fairly simple just to reposition the components and reroute the connections so I would have a functional board controlling both the ABS brakes and active suspension system. Then I just transferred the logic board design through to a three-dimensional representation to use within the mechanical assembly.
It's now time for Doug to finalize his design. To do so, he'll begin with a definition of the assembly and subassembly relationships of the entire vehicle. But Doug is only interested in the engine compartment, so he can go to his assembly tree and concentrate only on the components he needs to see.
I want to create a new subassembly for the design work that I want to incorporate. The ABS system, the modified active suspension system, and the enclosure box. Now, as I do this, my mechanical assembly is automatically updated.
Now that he has brought in these new assemblies, he can bring them out of his data management system and locate them where he wants them. The enclosure box is placed on the bulkhead, where Doug can run interference checks to reconfirm there are no clashes with the surrounding components. It's fine where he's placed it.
Now, once I've placed the enclosure box, I can file that change in the assembly so that everyone involved in the project is updated. Now, as I do that, the PC board Evan created is already in place. Now, this interactivity within the assembly is not just with one member of the team, but with all of them, no matter where they are. Ray at Sabre, another supplier, our structural analyst who's been verifying these designs for me, our drafter who's been producing drawings, or our technical illustrator who's been creating exploded assembly drawings.
Back at Sabre, the virtual team leader, Ray, has had his own form of interactivity by means of his own virtual tool, the virtual station.
All along the process, I want to keep tabs on how it's progressing. I can do so easily and efficiently with the virtual station. It's a state-of-the-art multimedia tool, which automatically goes out to every application that a member of the team might be using, extracts the pertinent information, and then assembles it in document form for me to browse whenever I need to see how things are going.
As Ray looks through his virtual station document, he sees that the concept has been accepted and the electrical system design is complete. Each page represents a different task area of the development cycle. Those which are not complete may cause him to redline them, to call out a question on a particular area, as he's done here, looking for the control box location. Since Doug has just completed the placement of the control box, when Ray refreshes his document, that particular information is updated, and Ray sees by the check mark on the index page that the mechanical design has been completed. By turning back to that page, he now sees the control box location as well as the suspension assembly and the ABS brake system details on the bottom of the page. The in-work design is complete. It's now time to build a prototype and road test it, the next step in the process. These tests are performed both on the road and in the laboratory. The results derived from them are then benchmarked against the mechanical analysis tests that were performed on the CAD models. Ray can easily see these results on the test page of his virtual station document. They prove out what is found in more and more cases. The time to complete a successful road test is significantly reduced because of the CAD analysis. All along the process, Ray has been updated through mail messages as well as by checking his virtual station document. Now, he receives a message that only he is authorized to approve, the final design.
All the road tests are complete, and Doug has requested an approval for the design. I can now review the entire process by looking through an updated version of my virtual station document. Now, every task has been completed successfully, so I can now approve the release of the design in my data management system and use the virtual station document as a best practices example for any future work in this area. By utilizing a collaborative system-oriented approach with IVS, we've been able to cut our development time by 60%.
We're able to seamlessly work with Sabre and other suppliers to share designs and information. The result is a cohesive virtual team that keeps the elite on top.
I know that the benefits I derive from this team-oriented system are magnified downstream by every other team member.
I'm confident that we've put together a strong, effective team with our people and our suppliers. I'm confident that their work is at the optimal level. And I'm confident that working this way will keep the Sabre Elite right where it belongs. Number one,